Given question, a 500 Newton roller is loaded between the cross pieces which are pinned at point C. Determine the tension in the horizontal rope DE, assuming a smooth floor.
Let us understand given question with the help of diagram. A roller of weight 500 Newton is placed on two cross pieces which are placed at point C. That means these two pieces are free to rotate about the point C. Cross pieces making an angle of 60 degree at point C as shown in the diagram. If we observe, these two cross pieces rest on horizontal surface at point A as well as at point B. Now we will consider the equilibrium of whole system. So we have to show the weight of roller 500 Newton which will act in vertically downward direction passing through the center. So I will show here 500 Newton. We have to show reaction at point A and at point B. So surface is horizontal, so we have to show reactions perpendicular to the horizontal surface, that means in vertical direction, and we have to show direction towards these cross pieces. So at point A we will say reaction is RA and at point B reaction is RB. Now this weight 500 Newton is equally distributed at RA and RB. So we can say that RA is equal to RB and RA plus RB is equal to 500 Newton. So we will write here RA plus RB is equal to 500 Newton and therefore RA is equal to RB is equal to 250 Newton. Now we will consider equilibrium of roller. Now roller is having weight of 500 Newton and which will act in vertically downward direction passing through center. So we have to show this. If we observe, roller is in contact with the crossed pieces. Now when it is in contact with cross pieces B to D, we will consider here suffix 1, and when it is in contact with A to E, we will consider suffix 2. Now we have to show the reaction force for this point of contact. So we will show the reaction because here the surface of contact is inclined surface. So we have to show reaction which is perpendicular to this inclined line B to D. So we will show here R1 which is in perpendicular to the inclined line B to D, and in the same way we will show here R2, that is the reaction which is also perpendicular to the inclined line A to E. Now if we extend this R1 and R2, they will meet at the center point of the roller. So we will show here one construction. Now how to find out the angle of this R1 and R2 made by this vertical line. So if we observe here, AE is making an angle of 60 degree with horizontal surface AB. So if we observe here this fixed horizontal surface. Now if we show here this R2 is perpendicular to this AE and this vertical line is perpendicular to the horizontal surface, then the angle at the point of contact in between these two perpendicular lines is also same, that is equal to 60 degree. So I will show here 60 degree angle. Now in the same way, if we observe, this B to D is inclined line and it is also making an angle of 60 degree with horizontal surface. So R1 is perpendicular to this, and for this horizontal surface this is the vertical line perpendicular to the horizontal surface. So at the point of contact in between these two perpendicular line is angle is same, that is equal to 60 degree. We will consider the equilibrium of the cross piece A to E. If we observe, this point A is in contact with horizontal surface and reaction RA is in upward direction. So at point A we will show reaction in vertical direction, and this Ra is equal to 250 Newton. Now we will move to the next point C. At point C, two cross pieces AE and BD are free to rotate. So reaction will be in any direction. So we will show horizontal component and vertical component of the reaction at point C. So horizontal component we will say RCX, and vertical component we will say RCY. Roller is in contact with cross piece AE at point 2. So we have to show reaction which will be in perpendicular direction to the inclined line A to E. Now for this reaction we have to show direction towards this AE, because this is the free body diagram of the cross piece AE. So here is the point 2, and we will show here reaction R2. We have to find out tension developed in the string D to E. Now this string DE is extensible. So tension will be always in outward direction from this AE. So we have to show the direction of tension T is in the outward direction, and we have to find out value of T. So I will show here tension T. Now we will move to the calculation part. We will consider the equilibrium of the roller. Then summation of all horizontal forces is equal to 0, and summation of all vertical forces is equal to 0. So we will first resolve this R1 and R2 into horizontal component and vertical component. So I will show here horizontal component, and here is the vertical component. For R2 also horizontal component and vertical component. Now how to decide its value? So if we observe, this vertical component is parallel to this vertical line, and this vertical line is nearby to angle 60 degree. So its value is R2 cos of 60. And for this R1 vertical component also, it is R1 cos of 60, because it is nearby to angle 60 degree. And now for horizontal component we have to show R2 sine of 60, and here R1 sine of 60. Now we will show summation of all horizontal forces is equal to 0. So here two horizontal forces R1 sine 60 and R2 sine 60, which are opposite in direction. So we will show here R1 sine 60 is equal to R2 sine 60. Then sine 60 is getting cancelled, and we can say that R1 is equal to R2. So I will make under. Now we will move to the next. Summation of all vertical forces is equal to 0. So from diagram, if we observe, these two are in upward direction and this 500 Newton is in downward direction. So we can say that R1 cos 60 plus R2 cos 60 is equal to 500 Newton. But we know that R1 is equal to R2. So instead of this R2, we can place R1. So we can say that 2R1 cos of 60 is equal to 500, and therefore R1 is equal to 500 Newton, and which is equal to R2. So this is the value of R1 and R2 we get from the equilibrium of the roller. Now we will use this value of R2 for this equilibrium of this member AE. So here R2 is equal to 500 Newton, and we have to show that. Now if we observe this equilibrium diagram, then here Ra is known 250 Newton, R2 is also known 500 Newton, but the forces at point C, that is the horizontal component and vertical component, is not known. And question is, we have to find out tension T in the diagram. So we will take the moment of all these forces about the point C. And when we consider the equilibrium of this member AE, then the moment of all the forces about the moment center C is equal to 0. Now when we take moment of all forces about point C, then at point C RCY and RCX acts. So here no any perpendicular distance and this distance is equal to 0. So these two forces RCY and RCX become 0. Now we will move to the next, that is the first force is T. So how to find out the moment about this point C? So we know that force multiplied by perpendicular distance. So here is the line of action of this force T. That is the outward direction from the member AE. Now from the point C, if I draw one vertical line or if I draw perpendicular line, then here we have to find out this perpendicular distance. So if this point of intersection, I will say X. Now in diagram we have given at point E, member AE is making an angle 60 degree with horizontal. Now this string is also horizontal and here also angle is same, that is 60 degree. If we observe in between these two horizontal lines, this is common inclined line AE and these two are the opposite angles. So if we observe the triangle CXE, then we have to find out this C to X distance. How to find out? So this distance C to E is known 1.8. And how to find out this distance? So from triangle we can say that it is Cx is equal to sine of 60. That is 1.8 into sine of 60. So we will take this T multiplied by 1.8 sine of 60. Now if I move the compass about this point C in the direction of T, then here is the direction. So this is the anti-clockwise direction and for this direction we will use positive sign. So we can use any sign. So for the clockwise direction we have to use negative sign. So if I use here positive sign, then T sine 60 into 1.8. Now we will move to the next, that is next force R2. So here also we have to find out the perpendicular distance. Now if we observe this R2 is in perpendicular to this C to E or this member AE. So we have to find out this distance C to F. Now if I move the compass about this point C in the direction of R2, then here is the clockwise direction. So we have to use the negative sign. So we can say that minus R2 into CF. So how to find out CF? So for that we will move to the diagram of the roller. So here is the center point O, this is the point of contact F and this is the point of contact pinned at this point C. So this is the C. Now we will observe here this triangle COF. Now in this triangle COF, diameter of the roller is given, that is equal to 1 meter. So this distance OF, that is the radius and which is equal to 0.5 meter. So OF is known, which is equal to 0.5 meter. Angle is also known, angle COF is known. Now if I take tan of 60 degree, so tan of 60 degree, that means opposite side divided by nearby side. So opposite side is CF, that we have to find out, and nearby side is OF and which is equal to 0.5 meter. So tan of 60 is equal to CF by OF, therefore CF is equal to 0.5 tan 60 and which is equal to 0.866 meter. So here R2 is equal to 500 Newton and CF is equal to 0.866 we have to put. Now we will move to the next. So next is RA. Now for this RA also we have to find out the moment. So we know that this line of action of RA I will show here in the form of dotted line. And now from point C we have to find out perpendicular distance. So here is this perpendicular distance. So suppose this point is point C and if this point of intersection, suppose I will say Y, then here is the triangle AYC. Now in this triangle AYC we have to find out the distance YC. So how to find out? Now if we observe, this YC is horizontal line and here also this horizontal line, and this is the common inclined line AC. So these are opposite angle and this angle is 60 degree. Now if we observe, this AC is known. Now in the triangle AYC, this is the perpendicular triangle and here angle is known 60 degree and we have to find out nearby side. So we can say that it is equal to AC cos of 60. YC is equal to AC cos of 60 and AC is known 1.2 meter. So we can say that this equal to 1.2 into cos of 60 multiplied by RA. Now how to find out its a sign, that is positive or negative. Now about this point C, if I move the compass in the direction of RA, so here is the direction. This is the direction and this is the clockwise direction, so use negative sign. So we can say that minus RA into 1.2 cos of 60 is equal to 0. So all the values are known except T, and therefore T is equal to 374 Newton.